Hello, my name is Mila Thomas, and for my final project, I decided to do light intensity. What is it? Light intensity is the power delivered by light per unit area of light. To break it down, as seen in the diagram, the more distance you place between yourself and the light source, the less intense the light will be, even though the original light source is still giving off the same amount of power. Light intensity's variable is EV, and in astronomy, light intensity is used to measure astronomical distance. Henrietta Swan Leavitt, the woman who discovered how to measure the universe. Henrietta Swan Leavitt was a Harvard computer in the early 1900s who studied photographic plates for fundamental properties of stars. She analyzed the brightness of stars using these plates. She often did comparisons, and in these comparisons, she would overlay one plate on top of another to see how the star has changed its brightness between each exposure. She discovered that some of these stars had a consistent brightness no matter where they are located, making these stars a good measuring stick for astronomical distances. Her work helped astronomers like Edwin Hubble measure galaxies' distances in the 1920s, which led to his realization that the universe is still expanding. Her work also helped Harlow Shapley figure out distances around the Milky Way, and her work is still being used today. Leavitt was not credited for her work until a couple years ago. The inverse square law describes the intensity of a light at different distances from a light source. Every light source is different, but the intensity changes in the same way. The intensity of a light is inversely proportional to the square of the distance. This means that as the distance from a light source increases, the intensity of the light decreases. The equation for a light intensity to find the distance is 1 over distance squared. Interesting facts/research. Stellar parallax. Stellar parallax is the difference in direction of a celestial object as seen by an observer from two widely separated points. The measurement of a parallax is used to directly find the distance of a body from the Earth and from the Sun. A very simple way to put this is it is a shift in position of a nearby object against a faraway object. I have a little experiment so we can better understand this. Hold your thumb out in front of you. Close one eye and look where your thumb is in relation to something far away. Now, open your eye and close your other one. It should look like it's moved compared to the faraway object. If you switch your eyes back and forth, it looks like your thumb is moving. That's a parallax, and it has to do with seeing something far away from two different points. In relation to astronomy, if you look at the diagram, you see they measure a star. Scientists measure a star's position in June and in July relative to the sun. And this allows them to see the movement in between the 6 months. Some interesting facts I found while doing my research is the closest star, Proxima Centauri, is 4.246 light years away from the Earth, and it would take about 73,000 years to get there. Light travels at a speed of about 300,000 kilometers per second, and the speed of light changes when traveling through different objects. Some subtopics I found are stellar parallax, which I mentioned earlier. That is the measuring of stars that are under 100 light years away. Stars that are over 100 light years away are measured with something called standard candles, which is a light source of a known standard luminosity. If we measure the apparent brightness of a sun-like star, we can assume it has the same luminosity as the sun and use the inverse square law for light to estimate its distance. Basically, if you know you have the same source strength of light, then counting the number of photons through a standard area detector tells you the distance of the source. Current research. I couldn't find much on light intensity, but I did find this article about the New World Atlas of Artificial Night Sky Brightness. Basically, the article talked about how the satellites that we send into space are negatively affecting our light pollution, which is the alternation of natural lightning levels caused by anthropocentric sources of lights, and is messing up our environment. And now they're putting a bunch of money into it to figure out how to fix it.